Replacing a three-phase motor with a 115-volt single-phase motor will not work without modifications. A three-phase motor needs a three-phase power source, while a 115-volt single-phase motor needs a single-phase power source. The motor windings, connections, and starting components differ between the two types of motors. Modifications to the wiring, connections, and starter are necessary to replace the three-phase motor with a single-phase motor. Regarding the 30-degree offset formula, there is no specific formula provided in the National Electrical Code for a 30-degree offset. However, a common method used to calculate offsets is the offset factor method. The offset factor is calculated as the offset distance divided by the conductor length. The offset distance represents the horizontal distance between the original support point and the new support point. The conductor length represents the total length of the conductor between the two support points. To determine the offset for a 30-degree angle, firstly, convert 30 degrees to radians. You do this by multiplying 30 degrees by pi divided by 180 degrees, which equals 0.524 radians. Secondly, calculate the sine of the angle, which is sin of 0.524, which equals 0.788. Thirdly, multiply the offset factor by the conductor length, so 0.788 times the conductor length equals the offset distance. For example, if the conductor length is 10 feet and you want to create a 30-degree offset, the offset distance equals 0.788 times 10 feet, which equals 7.88 feet. Let's elaborate further on motor replacement. When you're dealing with electrical motors, particularly when considering replacing one type with another, it's crucial to understand the fundamental differences in their power requirements and operational characteristics. A three-phase motor is designed to operate on a three-phase power supply, which consists of three alternating current signals that are out of phase with each other. This configuration provides a more consistent and efficient power delivery compared to a single-phase system. The three-phase power results in a rotating magnetic field within the motor, which drives the rotor and produces mechanical energy. On the other hand, a 115-volt single-phase motor operates on a single-phase power supply. This type of power supply delivers a single alternating current signal. Single-phase motors typically require additional components, such as capacitors, to create a starting torque and maintain rotation. Internal construction of these motors, including the windings and connections, is specifically designed to match the characteristics of their respective power supplies. When you attempt to replace a three-phase motor with a single-phase motor, you are essentially trying to power a device designed for one type of power with a completely different type. This is not a simple plug-and-play situation and requires significant modifications. Firstly, the wiring and connections will need to be altered. Three-phase motors have 3 power lines, while single-phase motors have only 2, plus a neutral in some cases. Secondly, the motor starter, which is responsible for safely starting and stopping the motor, will need to be replaced or reconfigured to match the requirements of the single-phase motor. Thirdly, the control circuitry may also need adjustments to ensure proper operation and safety. Attempting to run a single-phase motor on a three-phase power supply, or vice versa, can result in motor failure, damage to the electrical system, and potentially hazardous situations. It is essential to consult with a qualified electrician or electrical engineer to assess the feasibility of such a replacement and to ensure that all necessary modifications are performed correctly and safely. These modifications should adhere to the National Electrical Code and any local electrical codes. Now let's discuss more about calculating conduit offsets. Conduit offsets are bends made in electrical conduit to navigate around obstructions or to change the direction of the conduit run. Calculating these offsets accurately is crucial for ensuring that the conduit run is neat, professional, and complies with electrical codes. A 30-degree offset is a common type of bend used in conduit installations. While the National Electrical Code does not provide a specific formula for calculating 30-degree offsets, it does provide guidelines for conduit bending and installation practices. The offset factor method is a widely used technique for calculating conduit offsets. This method relies on trigonometric principles to determine the required bend angles and distances. The offset factor is a constant value that corresponds to the angle of the bend. For a 30-degree offset, the offset factor is approximately 2.0. This means that the distance between the bends should be twice the desired offset distance. To calculate the offset distance, you can use the following formula: offset distance equals the sine of the angle times the hypotenuse. In this case, the angle is 30 degrees and the hypotenuse is the distance between the bends. The sine of 30 degrees is 0.5, so the formula simplifies to offset distance equals 0.5 times the distance between the bends. Alternatively, you can use the following formula: offset distance equals the tangent of half the angle times the setback. The setback is the distance from the end of the conduit to the start of the bend. The tangent of half of 30 degrees, which is 15 degrees, is approximately 0.268. So the formula becomes offset distance equals 0.268 times the setback. To determine the conduit length needed for the offset, you can use the following formula: conduit length equals the square root of the offset distance squared plus the setback squared. This formula is based on the Pythagorean theorem. Once you have calculated the required bend angles, distances, and conduit length, you can use a conduit bender to create the offset. Conduit benders come in various types, including hand benders, hydraulic benders, and electric benders. It is essential to use the correct type of bender for the size and type of conduit you are working with. When bending conduit, it is important to make smooth, gradual bends to avoid damaging the conduit. Sharp bends can reduce the conduit's carrying capacity and can also make it difficult to pull wires through the conduit. After bending the conduit, it is important to check the offset to ensure that it is accurate. You can use a level and a measuring tape to verify the offset distance and angle. If the offset is not accurate, you may need to make adjustments to the bend. Proper conduit bending techniques are essential for creating professional and code-compliant electrical installations. It is recommended to practice conduit bending on scrap pieces of conduit before working on a live project. In addition to the offset factor method, there are other methods for calculating conduit offsets. One such method is the trig table method. Trig tables provide pre-calculated values for various bend angles and offset distances. To use a trig table, you simply look up the desired bend angle and offset distance, and the table will provide the corresponding conduit length and setback. Another method is the use of conduit bending software. Conduit bending software can automate the calculation process and can also provide visual representations of the bend. This type of software can be particularly helpful for complex conduit runs. When working with electrical conduit, it is important to follow all safety precautions. Always disconnect the power before working on any electrical circuits. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of your surroundings and avoid contact with any energized equipment. In addition to calculating offsets, it is also important to understand the different types of conduit fittings. Conduit fittings are used to connect sections of conduit together and to attach conduit to electrical boxes and equipment. There are many different types of conduit fittings available, including couplings, connectors, elbows, tees, and boxes. Each type of fitting has a specific purpose and is designed for use with a particular type of conduit. When selecting conduit fittings, it is important to choose fittings that are compatible with the type of conduit you are using. It is also important to choose fittings that are rated for the environment in which they will be used. For example, fittings used in wet locations must be waterproof. Proper selection and installation of conduit fittings are essential for ensuring a safe and reliable electrical system. It is recommended to consult with a qualified electrician or electrical inspector if you have any questions about conduit fittings. Now consider the National Electrical Code, or NEC, which is a comprehensive set of standards and guidelines for electrical installations. The NEC is updated every 3 years and is widely adopted throughout the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of electrical systems and the people who use them. The NEC contains many articles that are relevant to conduit installations. For example, Article 344 covers rigid metal conduit, Article 348 covers electrical metallic tubing, and Article 352 covers rigid polyvinyl chloride conduit. These articles provide detailed requirements for the installation of these types of conduit. The NEC also contains articles that cover conduit fittings, such as Article 314, which covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. In addition to the NEC, many local jurisdictions have their own electrical codes. These codes may be more stringent than the NEC and may contain additional requirements. It is important to be familiar with the electrical codes that are in effect in your area. When working on electrical installations, it is always a good idea to consult with a qualified electrician or electrical inspector. These professionals can help you to ensure that your installation complies with all applicable codes and standards. They can also provide guidance on the proper selection and installation of electrical equipment. Remember, electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In summary, replacing a three-phase motor with a single-phase motor requires significant modifications to the wiring, connections, and starter. Calculating 30-degree conduit offsets involves using trigonometric principles and the offset factor method. Compliance with the National Electrical Code and local electrical codes is essential for ensuring a safe and code-compliant electrical installation. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns. And always prioritize safety when working with electrical systems. Consider some related topics. Firstly, electrical safety. Always prioritize safety when working with electricity. To energize circuits before working on them and use appropriate personal protective equipment. Secondly, conduit bending techniques. Practice proper conduit bending techniques to create accurate and professional-looking offsets and bends. Thirdly, National Electrical Code or NEC. Familiarize yourself with the National Electrical Code requirements for conduit installations and electrical safety. Fourthly, motor control circuits. Understand the differences between three-phase and single-phase motor control circuits and how to modify them. Fifthly, electrical troubleshooting. Develop troubleshooting skills to diagnose and repair electrical problems in motor circuits and conduit systems.